One important application of calculus is to sketch cubic graphs or polynomial graphs in general. We know that 2x plus 3, the graph is a linear. We also know that 2x squared plus 3x plus 4 will give me a parabola or a quadratic graph. So a cubic graph, the equation of polynomial in third degree, you can see 3x cubed plus 2x squared plus x, and this will give me a cubic graph. There are 4 shapes of a cubic graph. So general equation of a cubic graph is ax cubed plus bx squared plus cx plus d. There's a general cubic function. So there are 4 shapes. When a is positive, it has 2 shapes, and when a is negative, it has 2 shapes. So this is one of the shape. When a is positive, you can see here it starts from and then goes up, and it has 2 turning points. It reaches a maximum, drops, reaches a minimum, and again goes up. So this is one of the shape of when a is positive. This is the second shape when a is positive. Without the turning points, it again starts from the bottom. So a positive graph, it starts from left bottom. Right? So that is the key here. It starts from left bottom. Now the graph when a is negative. The graph here is when a is negative, it starts from a left top and drops and reaches a minimum, and then goes up again and reaches a maximum, and it again drops. So when a is negative, I start from left top. Now this is the shape of another when a is negative, again starting from left to top. This cubic graph has equal turning points. So it starts here with left top. So my starting point is left top when a is negative. When a is positive, I start from left bottom. I start from left bottom here. So in short, if I summarize, the 4 shapes, when a is positive, it starts from left bottom of the graph. When a is negative, it starts from left top of the graph. Now, with the turning points, you can see the turning points are here. There are 2 turning points. And there is a shape with no turning points. However, the graph here on the right bottom is different from the left one side. On left hand side, definitely there's no turning points, but here there are turning points, but we can't see the turning point clearly, distinctly. Actually, there are 2 turning points in a cubic graph, but they coincide, they are equal here. That is why the shape is different from one on the left hand side. So this is the summary of the 4 shapes of a cubic graph. Whenever we draw a graph, we must have these key points in our mind. One is the shape of the graph. That we have seen now. What is the shape of a cubic graph? Second is the intercepts, both x-intercepts and y-intercepts. So here, in the case of cubic graphs, we'll introduce a new concept. Actually, it's not an introduction. We already know something. We're going to apply it in a different way, which is called as factor theorem. Next, the turning points. Here is where we apply our calculus to determine the turning points, especially the x-coordinate of the turning points. Then asymptotes and axes of symmetry. And axes of symmetry and asymptotes are beyond the scope of cubic graphs. There's something of axis of symmetry, point of symmetry, but I'll discuss it later. But there are no asymptotes in the case of a cubic graph. So asymptotes, we don't have this. We don't want that. So we'll be discussing on these four things, that is shape, intercepts and turning points. Axis of symmetry, I will not discuss it. So there is a one point of axis. So now let's look at the x-intercepts. Allow me to start from the known things. We know this is a quadratic polynomial, and we know how to find the x-intercepts of a quadratic polynomial. To find the y-intercept is very straightforward and is applicable to all. That is, I make it f of 0. That means I put x is equal to 0 and find the y-intercept. So in this case, the constant will be the y-intercept is minus 6. So though my f of 0 is going to be negative 6, which is equal to 0. Negative 6 is my y-intercept. Now here it is. Now next is x-intercept. How we find x-intercept? F of x is equal to 0. I equate it to 0. Now I introduce a term. It's called the factor theorem. Now I am trying to show something on the calculator on solving quadratic equation or any polynomial equation. I use this mode setup. And I use this option number 3, which is called a table, and I type my equation of quadratic equation. So here my case is x squared. So I press here x squared, and then it is a plus 5, and then I press here x, and then minus 6 is equal to, right? So this is my equation here, and a g of x is a g of x. I don't require it. I press simply equal to, and I start from negative 5. So it's just an arbitrary number. You can start from any number of your choice. So I prefer to start from negative 5. I end at 5. So I start from negative 5 and end at 5. So how I move from negative 5, I move one step each. That is negative 5, negative 4, negative 3, negative 2. So it's one step. I increment is 1. That's how I use this to find the table. So here I get to see, if you look at the table, the negative 5. So if I substitute negative 5 in the quadratic equation, then it will be x squared plus 5x. I'll get negative 6. When I put negative 4, I get negative 10. I put negative 3, I put negative 12. Negative will give me again negative 2. Negative 1 is negative 10, 0. So now you see, when 1 is equal to 0, this is what. So here f of x is equal to 0. For what value? For x is equal to 1. So I note down that one. That x minus, that is when x is equal to 1, f of 1 is equal to 0. From the calculator, we have seen f of 1 is equal to 0. Now what the factor theorem states is that, when f of 1 is equal to 0, then x minus 1 is a factor of f of x. So this is called the factor theorem. That is, f of x is equal to f of x is a function. Then when f of a is equal to 0, then x minus a is a factor of f of x. So this is what the factor theorem states. So apply that factor theorem here. So when to solve for f of x, or f of x is equal to 0, I use my calculator and I found that f of 1 is equal to 0. Right? So here, what I'll do here, therefore x minus 1 is a factor of f of x. Therefore, here x squared minus plus 5 of x minus 6 is equal to, I can factorize it using this calculator, x minus 1. Remember, this is a quadratic. A quadratic will have 2 factors. A cubic will have 3 factors. Not necessarily, but we'll see if there is a possibility or not. So quadratic will definitely will have two factors. So one of the factor here I got is x minus 1. So now what I'll do now here is I'd find the second factor. I can continue with bigger numbers on the calculator to find the second factor. Sometimes it may not be possible, sometimes it may be possible using the step 1. So here the another simple factor is if I expand this one, I should get this, the original function. Therefore, I look at the fact is x, right? Therefore, x into x must give me definitely x. Therefore, that is x squared. So when I open the brackets, when I use the FOIL method. Now look at the constant. So very simple thing is constant. So negative, this is negative 1 times some number should give me negative 6. So that definitely has to be positive 6. So my factors are x minus 1 and x plus 6. When the factors are x minus 1 and x plus 6, therefore my solutions are, my intercepts are, x-intercepts are positive 1 and negative 6. X is equal to negative 1 or x is equal to negative 6. That is 1, 0 and negative 6, 0. So these are the factors. So apply this factor theorem to find the x-intercepts of a cubic polynomial. Let's understand this once again here. When f of a is equal to 0 for a given polynomial f of x, then x minus a is a factor. I change the sign of a. Then we also call f a as a 0 of the polynomial f of x. So we have different names here for this particular a. When I say solve for x, I call these solutions. I also call them as roots of the equation. I also call them as intercepts of the graph. I also call them as zeros of the polynomial. I also call them as a factor, which changing the sign as a factor of the polynomial. So the same thing, but we have different names. We have seen the shape of the cubic graph. We have discussed on finding the x-intercepts of a cubic graph. Now about the turning points. What I'm going to do now is, this is my one of the cubic graphs, and we have to find the turning points. We have to find the turning points. That's what we're going to do. To find the turning points, we use a method of calculus. We have seen that the derivative of a function is the gradient of the tangent at that point. So I'm going to draw a tangent at A. So if I move this point A, accordingly the tangent will change. Now, what do you think will be the line at the turning point? So I'm moving the point A I'm moving very slowly. So what do you think will be what a line will look like when is at the turning point? So at the turning point, you can see the line will be parallel to x-axis. Therefore, its gradient is 0. That means its derivative is 0. So let's go to the other turning point. I have to be move very slowly, yeah? Otherwise, it will jump. So now I come closer to the turning point. You can see the tangent is parallel to x-axis, and the gradient of this tangent will be 0. So therefore, I applied that knowledge here. So we apply that knowledge here at turning points of a cubic graph. At turning points, first derivative is equal to 0, and I solve for x, and I can solve for x, and then I can substitute that value of x into the function to find the y coordinates. So turning points, we also call them as stationary points, and stationary points we also call these points as the turning points. The turning points as local. This is here. You can see this is maximum. We call them as a local maximum. We call this one as local minimum points. Local minimum and local maximum are the words we use, or we also call them as maximum or minimum points of a graph. So here, let me try to explain once again here. At turning points, we apply the derivative and we equate it to 0 to find the x values, and I solve for x, then I solve for x. I'm getting only the turning points, the x coordinates of the turning points. Then I substitute these values in the original function to find the y values. And these turning points are also called as stationary points. We also call them as a maximum or minimum points. I'm going to show you a worked example of sketching a graph. F of x is equal to x cubed plus 3x squared minus 6x minus 8. Our first step is to calculate the intercepts. So my y-intercept I can straight away find is equal to 0, negative 8. So my constant is this negative 8 is my y-intercept, or I can substitute 0 in this function and I'll get negative 8. Now to calculate the x-intercepts, I resort using calculator. So here I am going to use my calculator. I press mode and my option number 3 here, and I make x cube. So it is alpha x cube, and then it is plus 3 alpha x squared minus 6 alpha x minus 8. So I type that, and I can skip g of x, and I can start from negative 5, and I will end up to 5. I can start from any number, maybe even negative 100 to 0. You can only thing is the minimum start with the minimum and end with the maximum. And the calculator's certain memory, therefore limit the number to 15 to 20 numbers. So I start from negative 5 and end at positive 5, and my step is 1. So on increment from negative 5 to 5 is 1. That is after negative 5, negative 4, negative 3, negative 2. So that is the meaning of increment. Step is 1, and you can see here 4, negative 4 is equal to 0. Therefore I'll take, so one of the solution of this is negative 4. Therefore I can write as f of negative 4 is equal to 0. Therefore x plus 4 is a factor by using my factor theorem. Therefore I can write x cube plus 3x squared minus 6x minus, I got one of the factors as x plus 4, and there is other factors here. So this is a cubic function, and one of the factors is linear. Therefore this factor, the second factor, has to be a quadratic. I write the general form of a quadratic equation, a quadratic function, which is ax squared plus bx plus c. Right? Now let's look at, now this has to be ax squared plus bx plus c. Now look at now here, a has to be 1 because x times x squared will give me x times x squared will give me x cube. Isn't it? When I use the FOIL method. Therefore my first term here is x squared, the quadratic. Now plus b, we do not know what b is. And next one is look at now this. There's the last term. The constant into constant must give me the constant, right? Therefore, 4 times -2 will give me -8. So what I'll do here, I will do here is that I'll put -2. I hope it is clear. So -4 +4 times -2 will give me -8. So I'm left with only to find the value of p. So what I can do is that I can actually, is an inspection method, which we can do is that look at the x terms only. So when x into 2, you can say x into 2 will give me -2x. So it's -2x, and then 4 into bx, right, plus 4bx. So no other terms involves x only. Okay, so a -2x plus bx, and that must be equal to -6x. Therefore, now I can solve for b. That is, how can I make it? So I can eliminate x. That is -2 plus 4b is equal to -6. And I solve for the 4b is equal to -6 plus 2. So 4b is equal to -4 and b is equal to -1. Therefore, my factors are x cubed plus 3x squared minus 6x minus 8. I got the factors as x plus 4 times x squared minus x minus 2. Now I can factorize this quadratic. I can factorize this quadratic alone, right? And I can use even use quadratic equation, this quadratic formula to solve this second factor, or alternatively I can use factorization as well. Therefore, there is a simple factorization of quadratic. So I get x and 2, x and x. So when I multiply, I get a -2, but the difference of those two numbers must be -1 difference. Therefore, I will make it as -2 and +1. So these are the factors of the cubic function x cubed plus 3x minus 6x plus 8. Therefore, x-intercepts are x is equal to -4, -1 and +2. Or else I can write as -4, 0, -1, 0 and +2, 0. Now, after determining the x-intercepts, now we have to find the turning points of the function. So we rely on calculus. So if we first find the first derivative, so first derivative is going to be f prime of x is equal to x cubed is going to be 3x squared. 3x squared will become 6x, and -6x will become -6, and -8 is 0. Therefore, my first derivative is this one. Now, at turning point, that is at local maximum or minimum, first derivative is equal to 0. So always remember that first derivative is 0 for maximum or minimum. That is 3x squared plus 6x minus 6 is equal to 0. I can use my calculator to solve for x using the quadratic formula. So I use my quadratic formula to solve for x. So what I'll do, I got two values here. That is x is equal to 0, 0.73 or x is equal to -2,73. I round off to 2 decimal places. Now I substitute this value in the original function. So these are the turning points. I got two turning points here. one is 0,73, other one is negative 2,73. So I substitute back into this to find the y coordinate of the turning points. I substitute this value into the original function. So y value of the function, y value of the turning point, I substitute in the original one. So y of tp, I get f of 0,73. I can substitute that in my, I might use my calculator, and I got, what will I get? I get positive 10 over 39. I get positive 10 over 39, and then y turning point I got as negative 2,73. No, this I got negative, and this has got positive 10,39. So this is the value that I got in my calculator. So I found the turning points here. So 0,73, negative 10,39, and negative 2,73, positive 10,39. So you have to do it in your own calculator and see whether these values match. Now we have to draw the graph. So first we look at the intercepts that we have. We have the intercepts as negative 4, 0. We have negative 1, 0, and 2, 0 were my intercepts. And my turning points were 0,73, negative 10,39, negative 2,73, and 10,39. So these are my turning points and my x-intercepts. So I put here negative 4, negative 1, and positive 2. They are my x-intercepts. And my y-intercept was 0, negative 8. 0, negative 8 minus y-intercept. So this you can see it was a positive graph, and therefore I start from left to bottom. So I go up there, I start from here. And now what will happen now? Here I have negative 2,7. So now somewhere is negative 2,73, and up there 10,39. 10,39. So I have this my first turning point. So this is my first turning point here. Negative 2,73, positive 10, right? Then I come down. And again my second turning point is at 0,73. Therefore, allow me to erase this one. Yeah. So here it is coming down, negative 1. Yeah. So this is going to be a second turning point, and then I turn up. So this is my graph, my second turning point and my first turning point. So negative 2,73, positive 10,39, and this is 0,73, and negative 10,39. So this is my graph. I start from left to bottom, and I reach the first turning point. Since it is first turning point is on the second quadrant. So I start from the third quadrant, and it's going up to the second quadrant. Therefore, there will be an x-intercept, which is 4. And again, I am coming down. You can see my next turning point. My next turning point it will be in the fourth quadrant. Therefore, I have to cross both the x-axis and the y-axis. Therefore, there is x-intercept and y-intercept. Then I move on to the first quadrant. Therefore, again there is an x-intercept here, which in this case is positive 2. So this is my graph where a is positive.